Hello. In this lesson, we're going to, as part of a review trigonometry, I would like to select some questions from homework to show you how these how ARD are being used. And this question is it says, so let me put the title: selected questions from homework. The first question I would like to work for is that in this question, we want to find the following. We want to find sine 2x, cosine 2x, tangent 2x, sine half of x, cosine half of x, tangent half of x, with some given information. Given, right? The first question we're going to talk about is example number 1, right? So the question, the information that was given to us was sine x equals to 12/13. Maybe I would choose a different question. You know, we did sine in the class. Maybe I would try cosine, okay? And this one is a cosine, okay? Cosine x is equal to 4/5, okay? And we're told x terminates in the first quadrant. Okay, all right. So how do we find sine 2x, cosine 2x, tangent 2x, sine half of x, cosine half x, and tangent half of x, right? So double angle and half angles. And first of all, of course, you may like to have the formula sheet next to you, or you may also remember the formula, right? The formula in the formula sheets, and they are in relationship to all of these, right? So we're going to put that on the side, right? So we're going to sine 2x equals to 2 times sine x cosine x, okay? And cosine 2x equals to, cosine 2x has 3 formula. One is a cosine square x minus sine square x. And the other one is 2 times cosine square x minus 1. And the third one is 1 minus 2 times sine square of x. Okay. Since we have a cosine x equals 4/5, so naturally we're going to choose the second formula. It's just plugging in, right? And tangent 2x is going to be sine of 2x over cosine of 2x, right? So once we find sine 2x and we found cosine 2x, finding tangent 2x is just a matter of, you know, plugging the numbers from what we got from earlier operation. Half angles, right? Half angles, oops. Right. Half angles, we have to decide the sign. We have to determine the sign, which is 1 minus cosine x divided by 2. Okay, so let me make sure you can read the, oops, sorry. I have a typo there, 175%. So that will make it work. So you can, it's 1 minus cosine x, cosine half x. That's going to be equals to plus minus. So we have to, when we apply these formula, we have to determine the sign, okay, according to where the half angle terminates. And tangent For tangent, we have 3 formula, but we don't need to use these 3 formula. We can just simply use sine half x over cosine half x and just plug in. So you can see, in order to find out all of these 6 items, what do we need? We need sine x, and we already have cosine x, and that's all, right? So all we have to find out is we have sine x. If we have sine x, then we can get sine 2x by plugging in. Okay, whoops. 2 is going to be outside here. I almost made a mistake, right? So you can see, looking ahead as what we need, we really just need a cosine x and sine x. Cosine x is given, so we just have to find sine x, right? So how do we find sine x? Well, we have a cosine x, and we know the angle terminates in the first quadrant, right? So let me use one of the pictures that we drew before, right? In the previous class, right here, right? This one here, right? And make some adjustment, Okay, we need to make some adjustment because the terminal in this case terminates in the first quadrant. So we don't need the other ones. Right? So we can keep the first one. And these are in the first one. Right. And the rest of it, we can just delete them all. Whoops. Right? Whoopsie. You know what? I hate this. I just have to redo it. Okay. I thought I can take some shortcut, but obviously it doesn't work that way. So I'm not going to struggle. I'm not going to fight. And I'm just going to do it over, right? No problem. So we're going to set up, okay, instead of just spending time to repair, so just create something new. So we got this information. And from the definition, right? So why this kind of question is simply ARD D to A, right? So this is the kind of question. It's ARD is from D D to A, because we want to solve. Yeah, we want to find out what a sine x is, right? So we kind of need to know where the terminal is. It's kind of D to A because we know the ratio. Excuse me. We know the ratio, and then we just have to find out the angle. But how much information about the angle? We just need to know the sine ratio of this angle, really. Okay, but from this information, right? What are we getting is that knowing the definition of cosine, that's going to be the red divided by r, right? So now we know that the red is equals to 4 and the r equals to 5, right? So luckily we actually recognize this triangle. It's a 3, 4, 5, right? And it terminates in the first quadrant, and then we already know the blue already, right? We know the blue already because this is a familiar triangle. So blue is going to be 3. And then we can draw the terminal. Okay, excuse me. I'm going to draw the terminal. For you, you can just draw it on your paper pencil. Okay, the red is 4, the blue is 3. So that's the terminal, right? And the point on the terminal, we're going to mark it, right? That's 4, 3. red is 4. That's the point on the terminal. And then there's a red and blue. There's a red and blue, right? So the red is, right? So the red, right? And the blue is, there we go, red and blue. You see, this is how we know from the definition, right? We can get A, or we can also get the other information, right? In this case, we're getting from one definition to the other definition. So it's not exactly our D to A, but it's something we can, okay? So now by this time, we find out that sine X equals to 3, which is the blue, over 5. So you can see this is what we get by using ARD, 3 over 5. So now we get cosine equals 4 over 5, sine equals 3 over 5. It's just a matter of substituting, right? So let's finish this piece. And plug in the numbers, and it's 2 times sine X is 3 over 5, and cosine X is 4 over 5. 4 over 5, right? Simplify, and we got 24 over 25. And the second one, we just plug in the numbers. Okay, we have 2 times cosine X squared. Cosine X is 4/5. So 4/5 squared minus 1, right? And and then we have 2 times 4 squared is 16, 5 squared is 25, minus 1. It looks like we need a common denominator. That common denominator is 25. So we have 25 over 25 to replace 1. And now we have, excuse me, we have the common denominator, which is 25. 2 times 16 is 32. 32 minus 25, that's 7. So 7 over 25, right? And for tangent 2x, we just have to substitute by what we got, right? Sine 2x equals to 24 over 25, and cosine 2x equals to 7 over 25. Right? Simplify this expression by multiplying the top by 25, multiply the bottom by the same number, so as if we have multiplied by 1. So in the end, we get 24 over 7. 24 over 7. And for the half angle, we only just need a cosine. We already have a cosine, right? But we need to determine the sign. We have to select the sign. Because X is in the first quadrant, right? So since X in the first quadrant, what does that mean? That means that X is between 0 and pi over 2, okay? So X is between 0 and pi over 2. It cannot be equals to 0. It cannot be equals to pi over 2 because cosine X is 4 over 5, right? So from this inequality, if I divide every term by half, right? Divide X by half, divide pi over 2 by half, that's going to be pi over 4, and divide 0 by half is still 0. So half of X is in the first quadrant as well. That means that half of X is in the first quadrant. If half of X in the first quadrant, that means this is going to be positive. Remove the sign. cosine is going to be positive because half of x in the first quadrant. So here we go. Now we can substitute. So we need to determine the sign before we do the substitution. Okay. So now let's plug in 1 minus cosine x, and that's going to be 4/5. Okay. And then simplify this expression, rationalize it as needed. Okay. So when we are working with this fraction, you look inside the parentheses, we need to have a common denominator, which is going to be 5/5. Okay, so 5/5 minus 4/5, that's going to be 1/5. Simplify this complex fraction inside the bracket. So we're going to multiply on both top and bottom by 5. So in the end, we are getting almost to the end, right? 1/5 times 5 is 1. So we got, and square root of 1 is 1. So it's 1 over square root of 10. Okay, and rationalize it. So I'm sure you know how to rationalize it, right? So we're going to multiply root 10 over 10. That's multiplied by 1. Principle number 1 is applied. So in the end, we get root 10 over 10. Okay. And for cosine half x, right, we already have decided on the sign, which is positive, and that's going to be equals to inside the square root. We're going to replace cosine x by 4/5. And we still need to find the common denominator. And this time we will get 5/5 as well, right? 5/5. So on the numerator, inside the bracket, the roots is going to be 9/5. 9/5. And multiply 5 on the top, multiply 5 in the bottom. And the top is going to be 9. Square root of 9 is going to be 3. Okay, so this is going to be square root of 9 over 10, right? Square root of 9 equals to 3. So at this point, we get 3 over root 10. Oops. Root 10. Hold on. Okay, root 10. And rationalize it like we did earlier, which we multiply root 10 with root 10 over root 10. Principle number 1 is used, so that equals to 3 over 10. 3 times root 10 over 10. Okay, and we're almost there. Next one, we have half angle sine for half angle cosine. So this is half angle sine divided by half angle cosine, right? Root 10 over 10 and root 10 over 10, these will be reduced. So in the end, we get 1/3. 1/3. That's finished. Okay. And the next one, I like to choose a question that has a negative sign, and the quadrant is going to be in the fourth quadrant. Okay, so this one I'm going to use is the same question. Okay, so the same title. Okay, we want to find all of these. Okay, we want to find all of these. But given, what's being given is that sine of x equals to equals to negative 5/13. 5/13. And the x is in quadrant 4. All right. So that's the situation. That's the situation. Okay. Well, in this situation, of course, as we saw the formula before, right? We just need sine x and cosine x. If we find sine x and cosine x, everything can be resolved, right? Because sine 2x is equals to 2 times sine x, cosine x, right? And cosine 2x, this time I'm going to choose the formula, which is this one, because we know sine x squared, we know sine x first, right? So it's just much easier. And tangent x and half x and all these angles can be found pretty handily if we can find sine x and cosine x. Okay, from our previous experience, tangent 2x will just be equals to sine 2x over cosine 2x. And for the half angles, we need to determine the sine. And we need to determine the sine beforehand, before we plug in. So that's going to be a little bit of work. But other than that, everything will be rather similar to the previous situation. Oops. Why did I delete that? Okay, sorry. Sine of half x. I deleted and I couldn't go back there. But anyway, so plus minus. So let us take our time instead of rushing it. When I rush it, sometimes I just make mistakes without knowing before it's too late. Okay, so this is a plus. You can see in this case, we need to determine for tangent half x, the formula is similar, except that this is going to be half x, right? So half x, half angle. Okay, so pretty straightforward, Okay, so this time I'm going to copy this over again, so I don't have to type it every time. Okay, so there we go. We know what we need. We need a cosine x, that's all. From sine x, we need to find cosine x. But this angle terminates in the fourth quadrant, Now, this definition, sine x equals to negative 5/13, certainly tell us that it's a negative 5/13. And this tells us what? This tells us the blue. Oh, my mouse is rebelling. Okay, blue over R. Okay, blue over R. So the blue is negative 5, right? So blue is negative 5. And R equals to 13. Picture that. Think about that, right? I think from the familiarity we have from what we have done so far, you probably have already guessed what will be the red. Right? Because once we know the red, we can find cosine x, right? So there we go. Still by definition, ARD. ARD is the key to every question. Any which way you do it. Okay, any which way you do it. All right, so I'm going to make some adjustment so I will have enough space or have somewhat proper number to mark. Okay, but when you draw these on a piece of paper, you really can just mark it. It doesn't have to be precise at all. Okay, But because I use the software and I want to make it as perfectly as possible, so that's why I have to go through this. And if you do it on paper, I would say it's much easier, much faster if you know what you're doing. Here, of course, we're teaching you how to do it. So we know the blue is -5, R is 13 in the fourth quadrant. So you have a terminal in the fourth quadrant. So the blue is going to be -5. -5. And the red is going to be 12. Okay, how do I know? Okay, so let's draw the picture and you know why I think I know. Okay, academic questions besides these special angles and some of the non-special angles are typically like 3, 4, 5, right? 5, 12, 13 in their different orders, right? So here's the terminal. Here's the terminal. There you go. That's the terminal. I'm sorry, I'm going to draw the terminal. Right, it's a straight line. And here we go. Here we go. Wait, whoops. No. I did it wrong. It needs to be a line. Yeah, so that's the terminal. Okay, so the blue is going to be this piece. Okay, so let me draw the blue and red. Okay. Blue, the red. So we know the blue. We know the blue. We know the red. We know the hypotenuse is 13. And we know the blue is 5, -5. So the red is going to be 12. Okay. By Pythagorean theorem. By Pythagorean theorem. That's, these are the academic questions, right? Academic questions. If they're not these special values, you can always figure out because the definition tells you so, right? So the red, so as the result by Pythagorean theorem, right? The red equals to what? Red equals to the square root of 13 squared minus -5 squared. Okay. The red is going to be positive because the terminal is in the first quadrant, right? So here you're going to 169 minus 25. So that's going to be root 144. Root 144 is 12. So if you need to know how to calculate it, calculate it once and you get it. So this is 12. As a result, we get sine x equals to the red over r. Red is 12, r is 13. That's how we find it. That's how we find it. In the fourth quadrant, cosine. Okay, cosine. In the fourth quadrant, sine is negative. Cosine is positive, right? Because red over r, red is positive. So here we go. We get these two numbers. Okay. And this number and that number. So it's just a matter of plugging in. And we also going to show you how to determine the sine of half angle for the half angle formula. Okay, so let's do the easy part first. Cosine, sine 2x equals to 2 times, right? Sine x is -5 over 13. And the other one is a cosine x that's going to be equals to 12 over 13. So the answer for double angle is going to be negative. Okay, 13 times 13, 169. And it's going to be a negative number. And 5 times 12, that's 60. Oops, 60. Can we reduce it? No, we can't. Okay, and the next one, we're gonna do 1 minus, you can use any formula really at this point, okay? Sine squared, and this is sine, right? Sine is -5/13, so we get this piece, right? And now we need a common denominator, but before that, the common denominator obviously is going to be 13 squared. So it's 169/169 minus -5/13 squared. That's going to be 169 under -5 squared is 25. 25 times 2 is 50. So in the end, we're getting 169 minus 50. That's going to be 119/169. Can we reduce it? I don't think so. And tangent double x, double angle is we're gonna take this, the sine 2x, right? Divided by cosine 2x. Okay. And simplify, the 169 will be reduced. So in the end, we get tangent, it's going to be a negative angle, -60/119. Okay, we just multiply if you, just in case you need that, 169, multiply 169. So we use principle number 1 to reduce it. Now, we need to determine the sign before we proceed. Okay. We know that x is in the 4th quadrant. X is in the 4th quadrant. What does that mean? What it means is that x is between -3π/2, okay, less than x, less than 2π. Okay, if this is the case, and we're going to divide both sides by 2, divide all 3 sides by 2. Okay, 2π divided by 2, we get pi, right? So this is pi. -3π/2 divided by 2, that's going to be a 4. Oops, it's a positive, sorry. Okay, so this means x is in the 4th quadrant between 3π/2 to 2π. Now, this piece telling us that half of x is in the 2nd quadrant. So half of x, okay? So this tells us half of x is in the 2nd quadrant, quadrant 2, right? Quadrant 2 is between π/2 to pi, counterclockwise. And what does that mean? Half x in the 2nd quadrant, sine half x will be positive, but cosine will be negative. Okay, right? So in the 2nd quadrant, sine is positive. That's it. So we just plug in cosine x. What is the cosine x? It's equals to 12/13. And that equals to, am I right? Yes, I think I am. Yeah, 12/13. Okay, just in case, just in case. All right, so now we got common denominator, which is going to be 13/13, subtracting 12/13, right? 12/13. And that's going to be 1/13, right? So that's going to be 1/13. 1/13. 1/13 divided by 2. Right? So multiply the top and the bottom by the same number 13. So we will end up to be 1 over 13 times 13, that's 1. Square root of 1 is 1. So the denominator is going to be root 26. Rationalize it, right? We're going to multiply root 26 over root 26. Root 26 over root 26. So in the end, we're equals to root 26 over 26. Simplified. The next one, be careful, and select a negative sign. Why? Because half angle in the second quadrant. So we're going to plug in the number. We have to attach the negative sign along the way. And this piece is 12 over 13. Okay. And the negative sign is going to be tagging along all the way. And now 1 is 13 over 13, right? 13 over 13. So that's going to be a negative of 25. 13 plus 12, that's 25. 25 over 13, and so this is gone. Okay, so we do the same trick, multiply 13 times 13. And what do we get in the end? So the top is going to be square root of 25. Square root of 25 is 5. The denominator is root 26. And rationalize it, right? We're going to multiply root 26 with over root 26, and we're getting negative, right? The denominator will be rationalized, 26, so 5 times root 26. That's cosine half angle. Sine half angle is just a matter of substituting. So sine half angle over cosine half angle, which is negative. Well, tangent half angles in the second quadrant is negative. So you can think of that, right? So we're on the right track. So we get a negative 1/5, right? Because this piece and these two pieces, this piece, they're reduced. And that's it. Okay. I think we have touched all these different cases. You should be able to handle most of the rest of them. So let me choose another question, which is in a different section, which I think will be in high demand, that kind of question. Okay, it's a composition of trig functions. Okay, composition of trig functions. And we'll take this opportunity to review, review all related concepts, right? We in the previous lesson of review, we did talk about those, but in this lesson, we're gonna review them. We're gonna review them as well, okay? Now, so this is gonna be example number 3. Example number 3, okay? This question asking us to find exact value. Find exact value without using a calculator. Okay, and we don't need these anymore. Why would I just leave them there? I'll leave them out there anyway. Okay. Let's look at this one. Okay, this question says tan of 2 times arctan of a negative 5 over 13. Okay. All right, so we have a double angle. We have a double angle. So first we need to understand the process. Okay, we need to understand the process. Make the font just a little bit smaller. So first we need to understand the process. So I'm going to put it at a think out aloud, right? Or on the scratch paper. You know that this is going to produce an angle. Okay, so -5/13 as a fraction, which is considered as a ratio, will be the input of arctan, right? Arctan. Okay, so arctan, so I'm going to put it here just randomly, omega, so produces an angle. This angle is going to be in the range of arctangent. The range of arctangent is -π/2 to π/2, right? We reviewed those concepts and we've been, we talk about these, long before, right? Let me show you. Oops, arctan, right? The output for arctan is between -π/2 to π/2 exclusive, right? Exclusive. All right, so these informations has tremendous application in our work. Okay, but in particular, you see this is a negative ratio. This is a negative ratio, right? If we review about arctan, right? I did that picture earlier, so I'm going to bring back that picture so I don't have to draw it again. Arctan. Okay, arctan, come back. There. No, this is arc cosine. Arctan. There. This is about arctan, right? We have reviewed, right? We reviewed this piece. Okay, so we just bring them all together, right? We just bring them all with us, right? And put it next to us and as a review, right? So the no-fly zone arctan is a one-to-one function, right? Arctan is a one-to-one function, and there's no fly zone, and these are the, so the output is between -π/2 to π/2 because it's a negative ratio, because the ratio is negative. So the angle is actually going to be, in particular, you can say in particular, okay? The angle A is going to be, I can call it theta. So how about we call it theta? Theta is actually, arctan, right? The theta of, if I introduce this piece as, oh gosh, sorry. This piece, this angle, if I assume that equals to theta, is going to be in this fourth quadrant, meaning that it's between -π/2 to 0, okay, in particular. And then we do the half angle. We do the double angle, right? So here we go, we got an idea. Because from this assumption, right? So from here, oops. From that piece of information, we know that tangent theta, with theta in the fourth quadrant, so tangent theta is going to be equals to -5/13. And what does that tell us? What does that tell us? Right? It's in the fourth quadrant. The angle is in the fourth quadrant. In the fourth quadrant, and by definition, it's y/x, right? Y/x is the definition, or blue over red. Blue over red. Right? Blue over red. So blue is going to be negative and red is going to be the positive. That's it, right? So that tells us the blue is going to be negative because in the fourth quadrant, and the red is going to be 13 positive. Okay. So red and blue are both known and in the fourth quadrant. So what do we do? What do we say? What do we say? So I'm going to draw the picture. I'm going to draw the picture. Just, you know what? I'm just going to draw the picture. I don't want to rely on those shortcuts because it might take me more time and I could make mistakes. So just do it, okay? I hope you guys are patient enough with me. Otherwise, you can take a break if you want, and then you can come back later, or do it on your own. Okay, do it, do your own stuff. Okay, so red is 13, blue is -5. So that basically tells us the point on the terminal. Okay, so 13 is red, blue is -5. And that's the terminal. Wait, what did I do? Oh, I need to make it a dot. Okay, so, and the terminal, there we go. And that's going to be a line. So the terminal is found. So this is not actually the usual, the usual like 5, 12, 13, because these numbers is not the 5, 12, 13 because the red is 12, right? So the hypotenuse is going to be, what? What is it going to be the hypotenuse? So let me draw the red and blue. You tell me what is going to be the hypotenuse. Okay. So red and blue. So now I'm going to draw the red. Right, so this is going to be the red. And the next one is going to be the blue. This one is the blue. There we go, red and blue. The blue is -5, the red is 13. So what is R? In the definition, the R is equals to what? The red squared plus the blue squared, right? So that's going to be 13 squared. So -5 squared, the blue squared, sorry, -5 squared plus 13 squared. So this is not going to be a perfect number. I'm sorry, guys, but it happens. It happens a lot, especially in real life. Okay, so it's 25 plus 169. I guarantee you this is not going to be a perfect number, but we can do it. Okay, this could happen. This could happen. Okay, 25 plus 169. What would that be? Is it going to be a 4, 9, 194, right? 194, is that right? 194, okay? 25 plus 169, let's put it on your scratch paper, 194. Good, we got it, 194. If you want to simplify it, you can, right? To see if this is divisible by 4. Why divisible by 4? Because √4 is 2. You can bring 1 out. So just quickly, without much ado, I think it doesn't simplify. So 194 is the R. So this is a totally not a special case at all. All right, so we found, tangent. From tangent theta, we got, the R equals to, the R in the definition, it's √194. And now let's see, what do we need? right? What do we need? Depends on which formula you use, okay? There are so many formula we can derive. So let's see what we can, what we need, right? So what we need to find out is what is tangent 2 times theta, double angle, okay? Regarding the double angle, there's so many formula, right? And one of the formula actually is, let me derive it for you, okay? Let me derive it for you. One of the formula is that tangent 2 theta, right? To derive that formula, we can use sine 2 theta divided by cosine 2 theta. We can use that, okay? So in that case, we're going to have to get sine theta multiply cosine theta, right? And we can use 1 minus, let me make the fonts just a little bit larger. Okay, so you can see we need sine 2 theta, cosine 2 theta. But if we look closely, right, cosine 2 theta equals to 2 times sine squared theta, not x theta, right? Before we plug in, because if we use this formula directly, we need to find sine theta and cosine theta, which we can, okay? But if before we use the formula, we do something like this, okay? This is what I propose. You divide both the top and bottom. Divide both the top and bottom on every term, okay? By cosine, wait, what am I doing here? I think I did something wrong, okay? So this piece, okay, divided by something, and that something we're gonna choose to be cosine squared theta. So we're gonna divide it by cosine squared theta. Okay, so we divide the top by cosine squared theta, the bottom by cosine squared theta. You know what, as a matter of fact, I'm gonna use the other formula, okay, cosine squared theta. Because there's 3 formula for cosine 2 theta, right? So I'm using the one that's cosine squared theta minus sine squared theta, okay? By doing so, right, so let me make the fonts larger so you can see everything better. You can see, look at the top. The top 1 cosine theta take away 1 of the cosine theta in the bottom. So on the top, we have 2 times tangent theta because you have left with sine theta over cosine theta. So that's tangent theta. The bottom, cosine squared theta divided into cosine squared theta, that's going to be 1. So 1 minus tangent squared theta. Okay, you see, along the way, we can use this formula, we can use this formula, we can use this formula. But it looks like this formula is the one that will give us the most convenience. So I'm going to use this formula for tangent 2 theta. Because to get what we need, we just have to plug in tangent theta. We don't even need to find the r. Oh gosh, if we found out this before, we don't even need to do this, guys. We don't even need to do this, okay? So I deleted it, right? So of course, we're gonna organize the terms. I'm gonna leave it here, okay? Because some of the information, you know, I'm gonna show you a version and how to show work. But before that, it's just a matter of plugging in, okay? So on the top is 2 times tangent theta is -5/13. There you go. And in the bottom, it's just 1 minus that negative 5 over 13 squared. That's it. And you simplify, right? The top is going to be negative, right? Negative 10 over 13. And the bottom we have 1 minus negative 5 over 13 inside the parentheses square. So we have 25 over 169. Okay, finding common denominator. Okay, finding common denominator in the bottom, right? So 169 over 169. 169. Okay, so now the entire thing is going to be negative. So I'm going to put the negative in the front, and the top is 10 over 13. The bottom is going to be 169 minus 25. That's 144 divided by 169. Simplify this further. Okay, so we multiply the top with 169, the bottom with 169, right? So in the end, we get a negative, and the top is going to be 13 times 10, so 130. The bottom is 144. All right. So for this piece of work, okay, let me show you how to show the work. In this piece, actually, showing work is not, it's not going to be very, very difficult. A lot of the things we did, we actually don't need to show. Okay, so I'm gonna show you a version of showing work. Okay, show work. Okay, right here. Okay, I'm making the fonts just a little bit smaller. So show work. Okay, for that piece. Okay, so first we're gonna assume this piece equals to that. Okay, and of course we know that, oh wait, we assume theta equals to, no, we assume this piece equals to theta. Okay, remove that. And of course we know theta is going to be in the first quadrant. I mean, this is almost not necessary, right? But it's good to show your reader, you know what to do. You know what you're doing. So now tangent theta is going to be equals to negative 5 over 13. Okay, negative 5 over 13. And you don't even need to draw the picture in this case. You don't need to show all of these at all. You don't need to show all of these at all because we don't need sine, cosine. But if we're asking for a sine of these, then you will need it. If we need a cosine of these, yes, we'll need it. But here we don't, right? So for the rest of it, we just plug in. Okay, so that's going to be equals to tangent 2 times theta, right? And to tangent 2 times theta. And then you're gonna bring this formula into the picture. Okay. The deriving can be done on the scratch paper, depending on whether your reader give you credit for doing that, right? And you just plug in and do the rest, and you're finished. You're finished. Then you're finished. Okay. Is the picture necessary? I would say the picture is optional. The picture is optional. Okay, the picture is optional. Okay, that's it. That's it. Okay. Let's see. I think I will do another one for you in the next lesson. Okay, I think this lesson is long enough. Okay, thank you for watching. Until next time.